Hello everybody, it's Mrs. Pound and we are studying Chapter 9 on chemical compounds from BGU Chemistry's 5th edition. Today we're going to be talking about Section 9.2 on covalent compounds. So our objectives today will be to explain why chemists use a prefix system for naming covalent compounds, name covalent compounds on the basis of their formulas, and write formulas for covalent compounds on the basis of their names. So, naming binary covalent compounds. We use the Greek prefixes that we discussed in hydrates. So, see your notes on hydrates for those prefixes. Mono, which means one, is not used for the first element in the name. Double vowels are omitted. The last element in the name ends in IDE. And the least electronegative element is first. Also, do not reduce to the lowest whole number because these are molecules. These are units. These are not formula units where it's a ratio. These are actual molecules. So we always leave the numbers. Even if it was a 2 and a 4, we would not reduce. A prefix system is needed to indicate how many atoms of each element are in a binary covalent compound. This is because they have multiple oxidation numbers, and so they can combine in many more different ways, and we have to keep track of that. So let's practice by naming a few things. So we have carbon and oxygen. We have CO. We see it's carbon and there's one of them, but we don't use mono for the first one. And we see one oxygen, so we do use mono and we change it to an IDE ending. So this would be carbon monoxide. And notice it wouldn't be monoxide because it's a double letter, and that's one of the rules. So I drop that double letter and I just call it monoxide. So no mono in front of the carbon, mono in front of the oxygen, but drop the O and change the ending to IDE. Let's try something similar, and this is the reason for the prefixes, because now I have CO2. So with CO2, again, carbon, but 2, the prefix is di, so this becomes carbon dioxide. And the IDE ending again. And this is the same. The IDE endings, it doesn't matter whether it's covalent or ionic, they all end with that. So P2O5. So we take the first one, it's phosphorus. So it would be 2 is diphosphorus. And then 5, penta. Oxygen is oxide. So we have diphosphorus pentoxide. Now, also the A is dropped here. There are some that you just kind of have to get a feel for. So it is pentoxide, not pentaoxide. It also kind of, you have to decide, does it kind of sound right like that? It sounds kind of like you're stuttering in the middle if you say pentaoxide. So just pentoxide sounds better. Here we have Cl2O. So dichlorine, and then since it's one oxygen and it's the second one, monoxide. So dichlorine monoxide, IDE ending. Here we have bromine and oxygen, so it would be 2, which is di, so dibromine. 3 would be trioxide. So dibromine trioxide. And then if we know the name, we should be able to write the formula. So here we have iodine heptafluoride. So we see here there's one iodine. There are, hepta would be 7 fluorines. So it's IF7 would be the formula. So our objectives today were to explain why chemists use a prefix system for naming covalent compounds, to name covalent compounds on the basis of their formulas, and write formulas for covalent compounds on the basis of their names. So don't forget your 5 questions in your notes, and we will be doing some practice on writing these formulas and writing the names.